Hello, welcome to the 1.4 notes on angle measures. So the first definition that we have here, our new word, is array. So what is array? It's a portion of a line. So imagine a line and you're only going to take one portion of it that has an initial point. It starts at an initial point. So in our case, this dot is a little bit above the A. Let's fill it in and make it not above it. And so it's going to continue infinitely towards in one direction. Okay, so from A to B, that would be array. It starts at A and goes towards B infinitely forever. So you take a line and you kind of just snip off one side of it. So it has a starting point, goes the other direction. How do we name it? What's the notation? Well, you could either write the words array AB. Now, the first letter has to be your initial point. It has to be. Because in this array, if you look at it, array AB would be completely different than if I was to draw array BA. BA would go the opposite direction. Okay, another way to write it is that little notation above it. You're going to put a little arrow and it's always going to point to the right. And again, this is always the initial point where it starts at. Initials where it's starting from. And then it's going towards B infinitely. Now, if I was to draw this ray, I'm going to use my initials. So let's say I have point A right here on the left and P over there. You would not write this as AP and then an arrow towards A. That's just not our typical notation. We always want to write it starting initial point, what point does it go towards infinitely, and then draw the arrow pointing to the right. Opposite rays means if I had a line here and I was to choose a point on it, so that point, if I chose B as my point, that point determines exactly two rays that are called opposite rays. Since both rays share a common endpoint, they are always going to be collinear. They're going to lie on the same line. So in our picture here, BA and BC are opposite rays. And if you put them together, they're going to be a line. They always are collinear. Okay, so a lot of times kids they tell me, oh, I'm confused about opposite rays. There's nothing to be really confused about. You have a line, pick a point, going from that point in one direction, then the other direction. Those are opposite rays. Together they form a line. They are collinear. Okay, so one of the things we're going to deal with a lot in this class throughout the year are angles. So what is an angle? It's when you take two rays and they share a common endpoint. They don't have to be opposite rays. So here, what we have drawn here is an angle. This is a side, because the sides are, the rays are called the sides. So we have a side here, and then we have a side down here. So in our case, BA is a side, and BC. They're not opposite rays, but they do have the same initial endpoint, and that is called the vertex. So here in our picture, B, this point is called the vertex. All right, so an angle is made up of two rays that come together at the vertex. All right, so there are three ways that you can potentially name an angle, not always. The first one, the preferred method, is to call this angle ABC. Now, what I want you to notice is that A is a point on the side, C is a point on the other side, and then in the middle, always, 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 you're going to put the point that represents the vertex. So here, angle ABC, if I was to tell you to look at it, if you're looking at angle ABC, your eyes should literally be looking in that order from A to B to C. Oh, that's the angle I'm looking at. Notice here, if I call it CBA, C is a side, A is a side, and in the middle, we're still going to put that vertex. The vertex still is the middle letter. It's the point that is the vertex. So if I told you to look at angle CBA, you're looking this way, you're still looking at that angle. All right, if I told you to look at angle BAC, hopefully your eyes are looking down left B up to A, going towards the right and down to C. That is a different angle. Angle BAC and angle CAB are not the same angle, okay? Another way is you can name it by its vertex. However, You can't always do that. You can only do this only when there's, sorry, my stylus is bad, when there's only one angle with this as their vertex. So I will draw a little sketch what it would look like if we had two angles that share a vertex. So say I had this situation, okay, and I'm going to call this DOG, and then let's put a D here. If I said angle O, there are three angles here at O. There are three different angles. There's DOG, which would be the same thing as GOD. There's angle DOT, or TOD is the same thing. And then there's angle GOT, or TOG. Hopefully you see that. We have 1, 2, and then the entire thing, three different angles there. So saying angle O, it's confusing. It's up in the air. Which angle are you discussing? Which one do you mean? So you would not be able to call that angle O. Here, if I say angle B, there's only one that's occurring at that point, so it's okay to call it angle B. And then the third way is sometimes on the inside of the angle there will be a number, and then you could call it angle 1. Now the numbers won't always be there, but if they are, you can name an angle with the number that's on the inside. All right, so now we're going to classify angles by the type of angle that it is. Types of angles. If you're classifying an angle, an acute classify it as potentially between 0 and 90 angle degrees. Is between our pictures down here. This first one, this is what is an acute angle, not to be confused with an ugly angle. Just kidding. Okay, so this is acute. It's greater than 0 degrees, but it has to be less than 90 degrees. A right angle is exactly 90 degrees, and we could put a little marking in the picture. A little square will show that that is a right angle. So this one is right. An obtuse angle is greater than 90, but at the same time it has to be less than 180. That is this case. And then the last one here is not drawn for us. I'm going to draw it. A straight angle. And here, this would be exactly 180 degrees. So anytime you have a straight line, it's 180 degrees. Remember, those are two opposite rays, but a straight angle is 180. So if you're classifying it, you would say it's acute, right, obtuse, or straight. Okay, so now our notation. Let's talk about the difference of if I write angle ABC versus this little m in front of angle ABC. What I'm talking about here is the actual angle. We are just talking about what is that angle called? Angle ABC. This, the way you would say this out loud, is the measure of angle ABC. That's how you would say it. That's why I'm putting quotation marks here. And this is always going to equal a number. Okay, a measure of an angle is going to equal some number, and our units are, for angles, units are in degrees. Like I said, 90 degrees earlier, the classification, that was all in degrees, or radians, which we will discuss later in the year. It's just a different measure of units for an angle. All right, so this is kind of, you could compare this to when we talked about segments. If I said segment AB, I'm just talking about the segment, versus this notation AB, that's asking you, whoops, no line there. A, capital B is just saying what is the distance from point A to point B. How long is segment AB? That's what the different notation is. So same thing here. Here we're just talking about the angle, we're naming it. Here we're asking you what is the measure of the angle. Your answer should be either an expression or a number or what have you. Okay, so now let's talk about congruent angles. This is very similar to congruent segments. Congruent angles are going to have the same measure. So we could say that the measure of angle dog is equal to the measure of angle cat. That's the same as saying that angle DOG is congruent to angle CAT. The way that you would show congruency in a picture is you would give each of the angles its own arc. So if I want to show that angle DOG is congruent to CAT, if I put one arc in DOG, I would put one little arc in CAT. If I did a double in DOG, I would do a double in CAT. A lot of times there's an arc with like a slash through it, like the congruency tick marks, but that automatically shows you by looking at the picture that those angles are congruent, which means they have the same measure. Because remember, measures of angles, these are numbers. The angles are congruent. So angle bisector is our next definition here. An angle bisector is a ray that's going to split an angle exactly in half. So it's kind of like a segment bisector, except it's always a ray, and it's always going to split the angle into two congruent angles. So here we have the double arc. So either you are told that QR is an angle bisector, and then you would know those angles are congruent, or if I knew those angles are congruent, the converse, I could say, okay, QR is the angle bisector. It's going to split it into two equal angles. All right, so our example here, there's a lot going on in this picture. We have a ton of angles. Some people would say there's only 3 here, but there's not. There's a lot of angles. For example, AEG, NEL, those are all separate angles. GEL, what have you. Okay, so it says EA and EL are opposite rays. All right, so on the bottom here, straight line. So that means the entire angle is 180 degrees. Then it says EG bisects angle NEL. NEL is this angle. So if EG bisects it, those two angles inside become congruent. So I'm going to mark that in my picture. This angle is congruent to this one. Then they gave me some measurements. They said the measure of angle GEL is 3x minus 11. So I'm going to label that in my picture. NEL, the entire thing. So I like to use a different color to kind of represent that the entire angle here is 5x plus 2, because it does get a little bit visually confusing sometimes with angles when they're overlapping like this. On a segment, I would just write that entire length on the bottom. But with angles, when you have to do the whole thing, it does at times look visually confusing. So I like to use different colors to signify it or symbolize it. Okay, so now that's all they gave me. And I have to find the measure of angle NEG, and I have to find the measure of angle AEN. Well, in order to find anything here, I have to find x. So I have to figure out an equation that's going to help me solve for x. Many times kids want to write, well, 3x minus 11 is equal to 5x plus 2. And again, you don't have to know anything about geometry, anything about angles, nothing to know that. How could part of something? 3x minus 11 is a part of that entire angle. How can a part of something equal the whole thing? The answer is it can't. So what I wrote here is very, very illogical. You can't have a part of an angle equal the entire angle. That's nonsense. But what I can do is, because these two are equal, right? They told me this angle and this angle, EG was a bisector. That means they're the same. What I do is I will double 3x minus 11. Like I said in the previous video with segments, I could take half of 5x plus 2, but again, half of 5x plus 2 is not, I don't get nice integer values, so I'm not even going to mess around with that. I'm not doing that. I'm just going to double 3x minus 11, because if that's 3x minus 11, this one's 3x minus 11, right? Okay, so now we distribute and get 6x minus 22 equals 5x plus 2, and let's solve this equation for x. So I'm going to subtract 5x from both sides. I get x minus 22 equals 2. X is going to equal 24. All right, but they didn't ask me for x. They wanted me to find the measure of angle NEG and the measure of angle AEN. All right, well, I needed x though, so it's not that I wasted time. The measure of angle NEG, these two angles are equal. NEG is going to equal the measure of angle GEL. They told me GEL is 3x, 3 times 24 then, minus 11. This gives me 72 minus 11, aka 61 degrees. Okay, so I get this angle 61 degrees, this angle 61 degrees. Why do I care about that? Because now I have to find angle AEN. AEN. Well, hold on. There's nowhere to plug x in. They didn't give me an expression for AEN. So this is where you have to kind of think, like, what can I use what do I know that's going to help me find AEN? I know that this entire angle here is 180 degrees. So to find angle NEA, AEN, it doesn't matter. I mean, if I write the letters or say them in the opposite order, it's the same angle. AEN is going to equal 180 minus 61 degrees minus 61 degrees. Right? I'm going to take away this 61 and this 61 from 180, and I will be left with what angle AEN is, and that is 58 degrees. All right, that is it. In class, you will be working on the 1.4 classwork. Thank you so much for watching. Have a good one. Bye.